Okay, let's get started. So a student after last class pointed me to this. So if you're still having trouble with the virtual machine and installing it, this student was able to get everything working without having VirtualBox or anything like that. So if you're still having issues, I would recommend doing this. But it's just, I prefer if you use the virtual machine because actually one student emailed me saying that this person got a 0 out on their assignment, whereas they tested it and it passed all the test cases. And it turns out that there's actually a difference between if you include one header versus another. On one platform, if you include a header, it compiles, namely on the virtual machine. And if you compile it on, say, a Mac or a Windows computer, it does not compile. So this is one reason why I'm trying to emphasize using one platform, namely the virtual machine, so that everyone has the same installation of everything. I didn't think we would encounter this sort of thing, but we actually did. So use the virtual machine if you can. If you can't, for whatever reason, try doing this option. If you can't, then you need to talk to one of us. Okay, any other questions? Assignment 1 should there are a few students that are still not completely graded yet. So when they're graded, I'll put a distribution up here, but it's not done yet. And I'll get assignment 2 solutions up this weekend. But any other questions? Okay, so last time we were talking about a lot of different things, but namely these logical operators. So if we want to make conditions for if statements are more complex than just comparing one value against another, sometimes you want some condition to be true and some other condition to be true, or one to be true or another to be true, or a combination thereof. So we were looking at using 3 different operators, which are up here. So and, or, and not. Then we looked at some examples of those. And we did some more. We talked about short circuit evaluation, which is if you compare with 2 different conditions, if you find out one value, then it may be possible to not check the other one. In the case of and, if one of them is false, there's no reason to check the other one because you know that the condition is going to be evaluated to false anyway. And a similar thing for or. So we talked about precedence. Although this is not really a good idea, what's a better idea than just writing a line like this? Yeah, just parenthesize everything to make everything more clear. The main purpose of this that we saw last time was to check if input is valid. So if it's not valid, then we can actually check this using conditionals. So if it's inside this range, then we consider it good. Otherwise, it is not a good input. And then we can deal with it accordingly. Yeah, so it's usually used for input validation, usually for range, reasonableness, still not sure what that is, valid menu choice, and we'll return to menu choice today, and 0 as a divisor. So if you know that you're going to be dividing by a user input, you better make sure that it's not equal to 0, because then the computer blows up. Not really. So then we switched gears a little bit and talked about scope. So because we have if statements and else statements now, they actually introduce a different kind of scope. So remember, variables, as we knew them before, you can use them from when they're declared down through the rest of the program. But here, we looked at scope again, and we thought, well, what if we declared a variable inside an if statement? Can we use it afterward, after the if statement? And the answer we found out was what? No, you couldn't do that. So, but we did find that if you declared a variable somewhere, and then down further there's an if statement, you can use the variable declared before inside the if statement. So basically what we have is that wherever it's declared, it can be used anywhere from there up until the matching closing curly brace. So if we have, so let's ignore this for a second. We'll get back to it. So if we have an if statement right here, and we have a variable x equal to 5, and then some condition, then we can use x inside here, because x is declared before the if statement, and the matching curly brace that closes for x is down here. So x can be used anywhere from line 21 to line 34. So anywhere from where it's declared down, but if I declare a variable y inside here, inside the if statement, then the matching closed curly brace is right here on 27. So y here can only be used from line 24 to 26. So it can't be used outside of its context in a certain sense. But it can be used in a deeper scope than what it was declared in. So x is in one scope. The if statement introduces a deeper level of scope, and so x can be used in that one. Okay, so that's where we ended last time. So let's return to menus. So if we have the user be presented with a menu, so like option A is this, option B is this, etc., then what we saw before is we can actually check, did the user enter option A by checking, is the user's input, the character input, equal to the character that we want, which is either capital A, lowercase a. We'll return to that, but let's just say capital A. Then we just say, is the choice equal to that thing? Question, what if I had one equal there? It would be an assignment, and what would actually happen? It will always be true. So remember double equals, or do what instead? A Yoda conditional. But you may think, well, what if the user enters an entire input, right? So instead of just a single character, we can compare characters, that's fine. But what if the user enters an entire string of text? How does, or maybe two strings of text, how does one actually compare two strings like this? So what actually happens is that it compares character for character along the way. And then at each point, if they're equal, you proceed to the next character, and then you keep going until there's a difference. And then when there's a difference, it's the same condition as if you're treating a single character with a single character. I'm not going to test exclusively on that, but it's just know that you can actually compare strings. But think of this. Is the behavior for comparing a string versus a string different than comparing an integer to an integer? Well, does an integer, for example, compare character in digit for digit along the way, or bit for bit? In some sense, yeah. But what if, for example, name 1 happens to be shorter than name 2, but it occurs late? So the way you can think of this is that greater for strings means later in the dictionary. So if you have an alphabetical listing of words, then 1 appears later. If that occurs, then the later one is greater than the earlier one. But think of this. Suppose that name 1 occurs later in the dictionary, but has shorter length than name 2. Okay? What about for numbers? So let's just say we're comparing two numbers. One of them is longer than the other one. Is the shorter one going to be greater than the longer one? No. So it actually behaves slightly differently. So even though there are some similarities, I grant you that, but there is a slight difference. So the cool thing here is that we've seen this before, where C++ can redefine what each operator means to adapt to a particular context. So if I'm comparing strings, I might as well be comparing them in dictionary order. it doesn't really make sense to compare them in a different order than that. So just note that you can compare strings like this. You can do equality comparison with strings, just doing equals equals, or not equal, greater, less than, all that stuff. Yeah, so don't worry about this last line. We're going to return to it in like a month or so. But C style strings, if you're curious, is the ones that are in double quotes. The things that I said aren't actually strings, but are close to them. Those are the things in double quotes, these things called C style strings. But just think of them as strings for now. Okay, but sometimes if we're presented with a lot of input, or maybe a lot of menus, or we need to check only if the input was a number or if it's a alphabetic character or something like that, what we could do is just say, is it lowercase a or lowercase b or lowercase c or dot 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 or lowercase z or capital A or capital B or... Does that sound fun? No. So there are these handy functions in this header. So if we include this CC type header, then what we can do is use these functions, and then we can actually get queries like, is the input from the user a digit, for example? Or is it lowercase? Or is it uppercase? And then we can infer some things from that. So just as a quick example to show that this works. So let's just say we have a character C, and then we C in the character C. Then what we could do is see if the character that was inputted was a number. So 0, 1, 2, dot, 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 or 9. Okay? For any other character, I don't care. I just want to check if it's one of those 10 possible characters. So I got to include the CC type header. I'm not going to actually run this. I'm just going to show you how to do it. So if we include the CC type header, then what we can do is just say if is, so I got to make sure I get this right, is digit. So if I check if is digit C, and so these functions, so all functions have some name in front of them, like is digit, and then parentheses, and then what are called arguments in between. We'll return to functions later, I promise. But this is actually how you would use is digit, or is alpha, or is alnum, etc. So then in here we can say, for example, C is a, or input is a digit, or something like that. So we can actually do this check a lot more easily instead of just saying if C equals 0, the character 0, or C equals 1, or so. You could do that, but is it fun? Well, yeah. So writing is digit or something like that is way easier than having to reinvent the wheel in some sense. So so my advice is, if you're doing something and it's in code, and it seems like you're doing either repetitively or it's just a long condition or something like that, chances are C++ already has a function that does it for you. And so the best advice that I can give is, if you encounter something like that, look it up first and then use it. So if C++ has this function, use it. Don't try to create more work for yourself than you have to. But a lot of the time, they don't have the thing that you want, so you have to rewrite it. But a lot of the time, you do. You don't, sorry. Any questions about testing characters? Yeah.
The previous slide where you were talking about how you use 1 equals its assignment.
Yeah.
After the if statement with menu choice, that variable just become a.
Yes. So the question is, like if we're looking inside this if statement right here, and we wanted to know the value of menu choice inside here, it actually does the assignment. So whatever menu choice was before, it is now capital A.
That's outside of scope, right? So So it's a sign.
Oh, okay, I see what you're saying. So let's just say that we are checking if the input is just the character 0 and nothing else. So, and let's just say I mistype and I do this. If I, for example, print out C down here, or I print C inside here, C does have the character 0 inside of it. So it is set to value 0, regardless of what was inputted before. So no matter what, this will be set to 0. It'll print 0 here, and it'll print 0 here, because it's modifying the variable declared over here. Other questions about this sort of thing? Yeah.
So the next slide that we were looking at.
Yeah.
Is that only for single characters? And
Yeah.
single digits? You can't use it for strings or larger numbers.
Yeah, that's correct. So the question is, can we use this for strings and whatnot? I wish we could, but we can't. So if we actually look that up, so let's look up the CC type header. So then let's look at is alpha, for instance. So if we look at the what is called the signature of the function, but what do you notice about, so ignore this part at the beginning, but what do you see here? Yeah, it takes an integer, but I thought these things take characters. But wait, so could I feed an integer, any integer from this? Yeah, so is alpha can actually work with any integer, but what do we usually want to use it with? Characters. But wait, so is a character an integer? Ah, so we talked about this before. A character is always an integer. They're the same thing. But it's just that characters are commonly associated with the actual character itself instead of the integer value that it holds. So like capital A, I think, is either 65 or something like that. We don't want to deal with the number 65. We want to deal with the character A, because it's a lot more intuitive to work with. So just note that if you see int like this and get confused, and then see down here, check if character is alphabetic. It is meant to be used with characters, not with integers. But it can take any integer here, apparently. Yeah, so unfortunately we can't use it with strings. Any other questions about this?
So if we use is alpha with like 65, would it tell you true?
It would tell you true. So if we did is alpha the number 65, then that would tell you true, because in ASCII that corresponds to, I forget, either lower or capital case A, in which case the answer is both yes.
That might be like misleading, because if you want to check.
Right. It's a little misleading. So dealing with the actual character is a lot easier because it's more intuitive, but it's the same thing. Other questions? Okay, so let's switch gears a little bit. Prepare for more horrible puns throughout the semester. You signed up for this. So I'm going to illustrate why we want to do this with an example. So it's the example I had up here. So let's just say we had a menu like this. And we have, let's just say 5 options, but you can, of course, generalize this to have like 100 options, for example. So let's just say that the goal here is to figure out what option the user selected. So did they select option A, B, C, D, or E, or something else? So tell me, how should I do this as we know it so far? What should I do? Well, before I even do that, I got to see in a character. So I got to make a character first, and then see in that character. And what was the way that we checked is the character equal to A or equal to B or etc.? Yeah, so if C equals the character A, we can't use one of the tricks from before because I'm only working with A, B, C, D, or E. I'm not working with just alphabetic characters or just numeric or whatever. So I actually do have to make the comparison here is equal to lowercase a, But otherwise, if C is lowercase b, we do something, else if C equals C, and then else if C equals the character D, else, let's just say they can only enter those 5 things. So the else here corresponds to the user entered E. So let's just make it simple. What do you notice about this? It's pretty repetitive, right? So it's just like, okay, we're writing else if C equals something, and then else if C equals blah, blah, blah. What if we make a mistake somewhere, like this? If we have like 100 options, would this be hard to find? Yeah. So wouldn't it be really nice to make this a lot easier to read? Yes. So let's actually consider that. So that's what switch is for. So switch, the only purpose of switch is to make this easier, to have a bunch of if-else conditions like this, and you're just checking equality. So like if the input is equal to this, else if the input is equal to this, else if, etc. Switch makes that far easier, and that's all it solves. It doesn't solve any other problem. I can convert any switch statement back into the if-else if chain. So there's nothing really special about switch other than it's a lot easier to use. I mean, that's kind of special, I guess. But so how does this actually work? So what we were doing before is we're looking at if C is equal to lowercase a, else if C equals lowercase b, etc. So what we're going to do is we're going to switch on that variable. In this case, the character that was inputted, the variable C that we had before. The cases here are the things that we're trying to check equality for. So the first case in our example would be case character A. And then from that, we do some statements. The second case would be case character B. Then the third case would be case character C. I know it's early and it's Friday, but and then the fourth one would be case character D. And then because we had an else at the bottom, that in this case would be a default statement. So think of default as else. So it has the same purpose as else. So if it wasn't caught by one of these cases earlier, it falls into the default case. So it's just like the else in an if-else chain. So just to yeah, go ahead.
So unlike the if-else if statements, you don't need to put curly brackets around the statements.
Yeah, that's actually something that I don't really like about this. You actually don't need to put curly brackets around the statement sets, which is kind of weird. But there's something more subtle that we're going to get to in a second. I mean, you could put curly brackets around this, but this is actually one of the only cases where you don't have to put curly braces. Yeah, and it's the convention not to. So, yeah, it's really weird. But it's a lot easier to write because we don't have these equal problems or a mistypo. All we just have is case something, we do stuff. Case something, do stuff. It's a lot easier to write. Okay, so how do we actually do this in our code? So what I'm going to show you right now is not complete, but it's just what we know so far. So following the template right here, let's just scoot this over. So what we're going to have is, switch on the character. So the character that was inputted is C in this case. Well, the name of it is called C. So we're going to switch on C. And then throughout the rest of the cases, we're not going to mention C at all. Okay? All we're going to mention are the values we want to compare against. So the values we want to compare against are lowercase a, b, c, and d. So we're going to have 4 cases. We don't care about the other one because that's the default case. So we're going to have case lowercase a, and then some stuff here. Then we're going to have a case b, some stuff, case c, some stuff, case d, some more stuff, and then the final one, which is the else from the if else chain, is now the default here. So if it's not A, B, C, or D, we want to funnel all of those down into the default statement. So we would have a default right here, and then some stuff. Isn't that a lot easier to read and write? Yeah.
Could you use your or operators in the same cases? Just say lowercase a or uppercase?
You can't use or like this because it's comparing one value here, but there is a way around that. And there is a way to say, okay, well, what if the user entered capital A and we want to match that with lowercase a? We can actually do that pretty easily here, and we're about to see how to do that. But it's a lot easier to read and write. Any questions just on the basics? Yeah.
This doesn't say it's equals.
Right. Yeah, so what's, you're correct. So there's no equals here, but so the way as it works is we're gonna look at the value of C right now. We're gonna compare it against equality with the character lowercase a first. So if it is equal to lowercase a, then we proceed into here. If it isn't equal to lowercase a, then we're gonna proceed down to the second one, which is it equal to lowercase b? If it is, then we do this.
So this can only compare quality. You can't use bigger than.
Yeah, correct. So one of the limitations of switch and cases here is that it only compares equality. It doesn't do inequality. It doesn't do less than, greater than, or anything like that. It's strict equality here. And moreover, you can only switch, as far as I know, maybe this changed, you can only switch on either integers or characters. You can't switch on strings. I think a very recent version of C++ fixed that. I'm not sure, but I'm pretty sure you can only work on integers and characters here. Okay. Yeah, go ahead.
Say if the first case was true, is it still going to run through the rest of the cases?
We're going to get through that, but yeah, we're going to get to precisely that.
So since every letter actually has a number that goes with it, what if you enter one of those numbers? Would it execute whichever letter it goes with?
So so you're asking if I enter the character 6 followed by the character 5?
Is that what C is?
So C is a single character. So if I entered, let's not speculate here. So let's actually run this. So if I run this, so if I enter 65, what do you think C is going to hold as its character? It's going to hold 6. Okay. In fact, okay, I don't know how that happened. Oh, I didn't save. That's why. Yeah. Well, actually, this will cause an error, but wish there was a faster way to remove these. But no, I do not want to license it. Let's just see. So if I enter 65, then so it prints 6. So yeah, so the input here is processed character for character. Because I'm processing CN here with a character, it's only going to look at one character at a time. And so it doesn't treat 65 as, it doesn't know that this was being inputted as an integer. If instead I did this, and then I'm going to do something that we haven't seen before. So ignore that. So if I enter 65 here, then it'll do the right thing. So because CN is processing this as an integer, so it's going to read everything as an integer, whereas before it processes everything as a character. So it's one character at a time. So it's 6 in that case.
So it probably wouldn't work, right? Because there's no alphabetical letter that corresponds to just a single digit number.
Correct. Yeah. So there's no alphabetic character that corresponds to a number in ASCII. Yeah. To a single digit in ASCII is what I meant. Yeah. But do we at least understand how this works? So it compares C to lowercase a. If it doesn't work, then goes to lowercase b. If it doesn't work, go to lowercase c. If it doesn't work, go to lowercase d. Then if it still doesn't work, it goes down to default no matter what. Could I leave the default case out like that? Yeah. So just like in an if-else chain, I can leave out the last else if I wanted to, if I didn't want to catch all the other cases. But here, let's just say we want to make this more easier for the user. Okay, so a few people were asking, well, what if we wanted to do something like this? We can't actually do something like this, but what if we wanted to do something like this? If it's equal to lowercase a or capital case A. Let's just say we wanted to make the program easier to use for the user. They can enter whatever case they want. So we're going to actually deal with that right soon. Yeah. So this is the things that we just talked about, nothing new. If it matches some expression, so 3 is actually really interesting. This is the thing I was talking about. So if it matches one of the expressions from what we know now, it's going to go through the entire rest of the switch statement. Okay? So if it, in our case, matches, say, case B, and it didn't match case A. Let's just say it first matches case B, then it's going to do the code inside case B, then do all the code inside case C, all the code inside case D, and all the code inside default. That's how it works by default. So, but is that something that we really want here? Not in this case, but what if instead we did this? And then statements here. Well, and let's just ignore BCD for now. So let's just say it matches lowercase a. Then we still do these statements right here that correspond to lowercase a and capital case A. If it doesn't match lowercase a and but it does match capital case A, we still do the statements that are right under it. And so therefore, if it matches one of the two cases, either lower or uppercase A, we're going to still do the same statements for both of them. So I don't have to retype the same thing over and over. So this is actually really nice if we want to have it be equal to some value or another value. But from what we know, we don't want it, if it comes into the A cases up here, we don't want it to come down into the B, C, D default cases later. We don't want that. So how do we actually do that? So that's something called break. So we're going to come across break several times in this class. We're not going to have a break, but we'll find a break here. So I'm just going to say right now, this example is not mine. It's from the publisher. So if you don't fit into female and male and think if you're not one of those, that's an invalid gender, you probably should get out more. But it's from the publisher, not me. So let's just make it easy, and let's just say there are only two. The break statement here is to get out of the switch statement. So the problem that we have now is if it enters one of the cases, it's going to go through the rest of the other cases. So what is commonly done is if you enter a case, do some code in that case, and don't want to do any other case, you put a break statement there, which exits the entire switch statement, doesn't do anything else in the switch statement. So how would we actually do this in our code? So let's just do something similar for B, C, and D. So let's just say we have a B, lowercase b, capital case B, and let's just say we only have those two to make it easy. So let's just say we have some statements up here. Then if we want to enter here and don't want to do the B cases later, then we got to do a break statement like this. So let's just say that you entered option A as an example. And then what will happen is if the user enters lower or capital case A, it's going to enter whichever the case may be, do the statements, namely the C out here, and then it's going to proceed to break, which means that it doesn't do any of these other cases in here. It just exits the entire switch statement, which is like the if-else chain that we had. If it enters one of the if conditions at some point, it doesn't do any of the other ones. But sometimes you do want it to enter one of the other cases, like here. So if we want to have it be capital agnostic, to be lower or uppercase, then we can do something like this, where we don't put a break after the lowercase a, but we do after both of them, so that it handles both of them at the same time. But is this kind of fun to write? Even though it's a lot easier than the if-else conditions, is this fun, writing lowercase a and then capital case A? So what could we do? What we could do is say, regardless of what the user's input is, make it always be lowercase. So if it was uppercase before, turn it into lowercase. And so then, at that point, the user's input, whatever it was, is now in lowercase. So I only have to treat the lowercase cases. And so it's not actually in the slides, but it's actually a pretty good idea to know how to do it. So there's, instead of an is upper function or an is lower function to test if a character is lower or uppercase, you can use something called a to lower or to upper function to convert it to be uppercase or lowercase. So let's just say we want to convert the user's input to always be lowercase. So then what we would do is this. So to digest this, to lower will take the character that we want to make lowercase as input, and then if it already is lowercase, nothing will change. If it's not an alphabetic character at all, nothing will change. But if it's an uppercase character, it'll be converted to its lowercase version. So if it's capital A that was inputted, it'll now be lowercase a, which is kind of cool. And so now, if we do this, then I don't have to worry about the uppercase versions because I know it'll never be uppercase, which is nice. So let's actually see this work. So let's just run this. If we enter lowercase a, it says you entered option A as expected because we entered lowercase a, but to lower on a lowercase value does not actually do anything. But if we rerun with capital A, it'll still do the same thing because it's converted to lowercase, which is pretty cool. And so it's a lot easier to work with. And of course, there's a to upper version for this if you want to work with uppercase. Any questions on switches and cases and to lower, to upper, that sort of thing? Yeah.
Well, the previous, like before you used the two lower, where you did case small a and case big A, how does the computer read it? Is it like you go through case lower a, then immediately read case upper a?
Yeah, good question. So so the question is, how does the computer actually do this? So what happens is it looks at the character. So let's just say it's lowercase a to be simple. Then what'll happen is it matches this case, right? So what'll happen is there any statement corresponding directly to lowercase a? Well, later, but directly to lowercase a. No. But is there a break statement there? No. So it continues on until a break statement is reached or you reach the end of the switch statement. So there's no break here, so we continue on. So here, it already matched this case right here, so I don't need to match this one because by default, it just keeps going once it matches a case until it hits a break statement. So regardless, it doesn't matter what the value is here. So it matches this case no matter what because it matched the one up here. And so from here, there are statements corresponding to capital A, and namely we'll do those. Oh, but now we found a break statement, meaning that since we ended up in this lowercase a version, we're going to hit the break down here and then therefore exit the switch statement. Conversely, if we enter capital A, do we match this first case? No, because capital A is not the same as lower a. But we do match this one. And so then we carry on in the exact same way as before. Yeah.
If it runs and then it hits a break statement, does it check to see? Does it check the other cases, or does it just go to the end of the switch?
So if it hits a break, it unconditionally exits the switch statement, regardless of what the value is. Or so I could, for example, do this. So I can combine lowercase a with capital C for all I want. And if you match one of those two cases, it'll execute these statements the same way. Okay, so once you hit a break statement, regardless of what was matched before, you exit the switch statement no matter what. Doesn't matter how many cases you did before. Yeah.
So you're saying without the break, if it hit like capital A, would it also do statements under?
Yes. So the question is, if I remove the break like that, in this case, if it matches lowercase or uppercase a, it'll continue all the way down. It'll do every single thing until it hits a break statement, but there isn't one in this case. Other questions?
So it's not possible to not use break.
No, it is possible to use to not use break like this one. So it's kind of stupid if I did this, but because if I'm trying to, each one of these options is exclusive from the other one. So if we want to enter A, we don't want to do any of the other ones, but I could do this if I wanted to.
But after the statement, the first CR statement where you enter option A, it wouldn't execute the next statement.
Oh yeah, it would.
No, like if it doesn't satisfy a case, it doesn't.
No, it'll still do them.
That's what you're saying.
So if you enter one of the cases, you keep going regardless of what happens until you hit a break statement or exit the switch statement. So if we did something like this, and let's just say we enter option A, it does both of them. So you may want to actually do this. In the case of like, if you want to bundle option A and B together, this would actually make sense. But in the case of this menu, it doesn't actually make sense because one option is different from the other. Yeah.
So if you only chose it because option B is program,
Yeah.
that only execute if you chose option B.
Right, so if I do either lowercase or uppercase b, it'll only do the second one. Because once you match the case, then it continues from there, but it doesn't do the ones before. Yeah, so it's only when you first match the case does it actually start mattering. Other questions? Okay, so this is just a one with gender. If it's equal to lowercase f, you do something. If you do lowercase m, you do something. Default is anything else, you do something else. All right, so this is basically what we just did. It's a natural choice for a menu-driven program because you're comparing the user's input against one value at a time. Is it this option, or is it this option, or this option, or this option, all the way through? Okay, but you may be thinking, okay, what if we had a menu like this, and let's just say we had like 20 options, for example, and one of them is lowercase a, lowercase b, lowercase c, up to lowercase t, because t is the 20th letter. The problem with that is that we're not really associating the character A with something else. So it's like we have to remember, okay, in our example here, option A corresponds to the first option. Option B corresponds to the second option. But if we're looking down here, do we really know what that really corresponds to? That doesn't really make sense. So an enum kind of solves this a little bit. So all an enum is, all it is just a renaming of integers. So if you have a bunch of integers or a bunch of options, for example, then all you do is you associate a name for each one of them. So if we wanted to have a bunch of fruits, I could say the first fruit option in the menu is 0 or A or whatever. And I can, instead of just working with 0 or lowercase a or something like that, I can just say apple there, or grape or orange. And so then if the user's input is equal to apple, then we can make a lot more sense of what is really going on here. Then we can check else if equal to grape, else if equal to orange, or even do a switch with it. So switch on the user's input, case apple, case grape, case orange. It works exactly the same way. But now it's a lot easier to read because now we can actually look at the case and go, oh, that is what the code is supposed to do. And then this case is what this code is supposed to do. You can do the same thing with any number of different things. So you can have the weekdays right here, and then we can just say if the user inputted Monday or Tuesday or Wednesday, Thursday, Friday, that sort of thing, which is really easy to read comparatively. So how would you actually do this? So what you would do is something like this. So let's just go up here, make a quick enum. Oops. Don't know why I didn't copy. There. So I'm going to enter right here to make it easier. So the enums right here is the first example of something where it's declared outside of the main function. Okay? So enums like this are typically declared outside of the main function, and that's the convention we'll deal with. We're not going to talk a lot about enums because they don't come up too often other than making code easier to read. But the way you do this is if you just leave it alone like this, then what will happen is apple is going to hold the value 0. So apple is the same thing as the value 0. Grape is going to have the value of 1. Orange is going to have the value of 2. But if you wanted to, you can have a default association like this. So I could just say apple equals 2, grape is 4, orange is 5 if I wanted to. So then if I wanted to, I could just say case apple like this. And then maybe a break in here, case grape with a break, and then a case orange break. And so this is far easier to read other than like case lowercase a or something. So fortunately, we're not going to come across this too much. So all it is just to make the code easier to read.
What happens if you assign something to that's already there? So if you call apple
Mm-hmm.
still go through?
So great question. So are the things inside an enum assignable outside of the enum? So they are assignable here. That's fine. But can you assign them out here? So let's just say I want to set apple equal to 1, for instance. So let's actually test. And it actually doesn't work. Does anyone know or have a hypothesis as to why?
It's not
That actually doesn't matter here. Yeah.
It's not a variable that's declared in the int.
Oh, so you two had kind of the same idea that it's declared outside of the main. That's not really an issue here.
Just set it as a constant.
Yeah. So what happens here is that apple is the same thing as the value 2. So what actually happens when the program compiles is that every instance of apple is going to be replaced with the value 2 everywhere in the program. So it's like literally copied and pasted the value 2 in the place of where apple is. So this is what will actually happen if you ran your program. This is what the compiler will actually see. And so this is not now a valid thing to do in C++. So that's why it actually gives us an error here, saying you can't assign. You can think of them like constants. Yeah.
So how would the user enter what they wanted? Would they just type the word apple, or would they?
Great question. We'll talk about that next time. Any other last-minute questions?
What if you assign two of cases specifically? So if you set apple equal to before and before?
You can't set them outside of the enum.
No, like right here, you like go up to if you set apple before and green, so what happens?
Oh, I think that'll work. Yeah, that'll work. Yeah, it is. But it's not bogus because what'll happen is every instance of apple is copied and pasted with the value independently of all the other parts in the enum. So that's why it works.